Okay, welcome back to part 2 of product and quotient rule, derivative techniques 1. I want to go ahead and let's go ahead and keep practicing this quotient rule thing to make sure you get the right idea. Again, the key to knowing when to use which tool is basically this. If I see division, that means I have an F over a G. That means that I am going to use my quotient rule. Again, your quotient rule states that your derivative with respect to x, or dy dx in this case, is going to be f prime times g minus f g prime all over g squared. And let's look at what we have. So our components are f is my top function, x minus 1, which makes my bottom, or my f prime, the derivative of 1x is 1, the derivative of the negative 1 is 0. My g is x squared plus 3, and my g prime is 2x, and that's pretty much it. And these get plugged into my quotient rule formula. So f prime is 1 times my g, which is x squared plus 3, minus my f, x minus 1 quantity, times my g prime, which is 2x, all over g squared, which is x squared plus 3 squared. And then again, like I said, if it's a free response, you don't have to distribute this out. And if it's a multiple choice, they're probably not going to make you distribute it out anyway, the bottom. The top, I'm going to have to goof with. So it gives me x squared plus 3 when I distribute to 1. Now, 2x times x is 2x squared, but I also have to distribute the negative, so that's negative 2x squared. 2x times negative 1 is negative 2x, negated is plus 2x. Then we just combine like terms. Let me just check that out. Okay. So I get x squared minus 2x squared, so I get negative x squared plus 2x plus 3, and all over my denominator, x squared plus 3, that quantity squared, and I'm good to go right there. That would more than likely be the type of answer you'll get on a multiple choice. Now's where it gets a little crazy here. There is a part B, so we found the derivative. We found y prime or f prime, whatever you want to call it. We have found that. That's what dy dx means. Now what it's asking is, when does this graph have horizontal tangents? Well, I know the graph may not look like this, and actually I'm quite sure it doesn't, but this is what are meant by horizontal tangents. That's when your tangent lines have a slope of 0. So your m tan is 0. So basically when I see this phrase right here, whenever I see a question that says find the horizontal tangents, basically what it's saying is to take the derivative and make it equal to 0 and then solve for x. Now, if it said at what points, I'd have to find the x's and the y's. The key here, it only says where, so I'm going to find the x values and I'm just going to call it a day. I'm going to be done. I don't need to find the y in this problem. Not going to volunteer too much information. So basically I take my f prime, which is right here, which gives me negative x squared plus 2x plus 3 all over that, x squared plus 3 squared. And since I'm looking for horizontal tangents, I know horizontal lines have a slope of 1, and I know f prime is the same as saying the slope of the tangent line. So a lot of people look at this and have this algebraic freakout kind of a thing. It's not that big a deal. Just think of it like this. If I had something like this, if I had like x over 3 equals 10, to get rid of the 3 on the bottom, I'd just multiply. So I'd get x equals 30. Now, we don't have that, but we have something similar. I have something on the bottom I want gone, so I'm going to multiply both sides, and again, this should be up top here. I'm going to multiply both sides by x squared plus 3 squared. So what does that do? Well, it gets rid of this bottom, so I get negative x squared plus 2x plus 3 equals, well, 0. So, well, wait just a minute here. So the bottom just canceled and it didn't do anything. Exactly. Whenever you have a fraction and it equals 0, what that means is that the top has to equal 0. The bottom can be any number you darn well please it to be. It really doesn't matter. The only way a fraction equals 0 is if the top is 0. So what I typically do is, I showed you that step about multiplying both sides by that denominator, but honestly what I do is when I have something like this, if I have f prime equaling some fraction a over b, and if I want to know where the horizontal tangents are, I'm just going to take the top and set it equal to 0. We'll talk about what happens when the bottom is 0 later. Well, okay, we can talk about it now. That's where you get your vertical tangents from. That's where your derivative is undefined, but we'll get to that in problems later on. So first thing I'm not real crazy about is I don't like my x squared's negative, so I'm going to do this. I'm going to take both sides and multiply them by -1. Now, again, is that legal to do? Well, yeah, think about it like this. If I have 2x plus 5 equals 10, what will be the first thing you do? You subtract 5, you subtract 5. Whatever you do to one side, it's legal to do to the other side in equation. Or it's legal to do so long as you do that same operation to the other side. So, yeah, so long as I do it to every side. So that gives me x squared minus 2x minus 3. And, well, that's still 0. Now you're going to find, if you want to run it through your quadratic, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. You can. I'm not going to. If you wanted to do that with completing the square, I can. I'm not going to. I like factoring. Factors of 3 are 3 and 1. I want them to add up to -2. So it's a -3 and a +1. So when I set x plus 1 equal to 0 and the other factor x minus 3 equal to 0, basically what I can tell you is that my function, did I name it something? Did I call it f of x? No, it's just, so your function has horizontal tangents at x equals -1 and x equals 3 if you were to finish solving those. Again, that's when it asks where. If it said at what points, then you'd have to go back to your original function right here and plug in the x values to get the corresponding y, but since we were not asked to do that, I'm not going to do that. Okay, a little calculus notation here. First off, I hope you see that I'm looking to find dy dx. This is y, so dy dx, same thing as saying y prime. So that much I know I'm going to have to do quotient rule because of this division. So again, my f, my top function, 3x squared minus 5x plus 2. My f prime using power rule is 6x minus 5. My g function from the bottom is 2x plus 7. My g prime is derivative of 2x, which is 2. Derivative of 7 is 0. And these are going to get plugged into, again, fg, prime the first, prime the last, minus over g squared. We'll worry about this little guy later. So what do I get? My f prime is 6x minus 5 times my g, 2x plus 7, minus my f, 3x squared minus 5x plus 2 times my g prime 2 all over my g, which is 2x plus 7, quantity squared. So there's my y prime. There's my first derivative. Now, if you want, you can do like we did in the past problems, to where you distributed, combined like terms, did all that funky junk on the top, and just left the bottom alone to get an answer. I'm not even going to do that this time. See, I know what this little thing means. What this basically means is to find your derivative and evaluate at x equals 1. So in other words, if this equation right here is my y prime, what this thing is actually telling me to do is to find y prime of 1. So rather than doing all this crazy distributing and whatever with all the variables and stuff, which I know can make it easy to make mistakes, I'm just going to plug 1 in right stinking now. So that's going to give me 6 times 1 minus 5, 2 times 1 plus 7, minus 3 times, or let me try that again, minus the quantity, 3 times 1 squared, 5 times 1 plus 2 times 2, all over 2 times 1 plus 7 squared. Now you're done with the variables. It's really easy. That makes 6 minus 5, that's 1. 2 times 1 is 2 plus 7, that's 9. Minus, that's 3 minus 5 is negative 2. Plus 2, that's 0. So, and the bottom, 2 times 1 plus 7 is 9. 9 squared is 81. So I basically get 9 minus 0 over 81, which is 9 over 81, which is 1/9. And there's your answer. So when you see this little notation here, it means derive, then plug in or evaluate at that location that it's given. Okay. Now let's get into some nasty stuff. So we've been dealing strictly with equations. So again, I am a big proponent of multiple representations, meaning I like verbal representations, I like tables, I like graphs, I like doing algebra. It's all those representations. So I need you prepared for every one. There was a problem similar to this on a previous AP test that gives a lot of kids fits, and I don't want to let that be a problem to you. I'm going to start off by doing this wrong. 3, and again, we're finding at 3, which is here, so I'm just going to plug in values. So f of x at 3 is 5 plus 2 times 5 minus g of x is negative 4, which is plus 4, which makes 15. That makes 17 times 9, and you say that's a 3. The answer is 153. No, that would still be h of x. This would basically be what is h of 3. This would be finding a y coordinate. That's not what I'm asking you for. I'm looking for what is the slope of the tangent at x equals 3. You say, okay, so then I take the derivative of that, which is 0. And that's right. No, no, no. It's all garbage. In a problem like this, I don't want you to even know that this table up here even exists yet. It is not of any importance to me until I find my derivative equation. See, don't plug in until you have a derivative to plug in. So, what do? Well, you're certainly welcome to distribute and power rule that if that makes you happy. This is probably one of those times where I find the product rule to be my friend. So, I have an f, which is this first polynomial here, 3fx's plus 2. And I have a g of x, or a g, which is 5 minus g of x. So my f prime is going to be 3f prime of x's, and the derivative of 2, because the derivative of f is f prime, the derivative of 3f's is 3f primes. And then g prime, well, the derivative of 5 is 0. The derivative of a negative g of x is a negative g prime of x. And that I'm going to plug into my fg, prime the first, prime the last, plus. And let's see what happens. So my f prime is 3 f prime of x's times my g, which is 5 minus g of x, plus my f, which is 3f of x's, plus 2, and then my g prime, which is negative g prime of x. So now we've at least found the formula for my derivative. Now we take care of this part. So now we evaluate the derivative at 3. So this basically makes 3 f prime of 3's, 5 minus g of 3, 3 f of 3's, plus 2 times negative g prime of 3. Once you get this equation all set up here, now we're ready to go table hunting. So I'm going to erase so I got some room here. And let's see what we got. So this says to take 3 times f of 3. So here's when x is 3, f is that. So instead of 3f of 3, I get 3 times 5. Times 5 minus, what is g of 3? G of 3 is negative 4. So 5 minus negative 4 is 5 plus 4. Plus 3. F of 3's is 5. Okay, I guess I goofed up there. No, let me see. Yeah, I absolutely goofed up. Let me try this again. So we're taking 3 times not f of 3, but f prime of 3, which is negative 3. That's better. Here, let me write that a little better here. So I get 3 f prime is negative 3 times 5 minus g, which is negative 4, so plus 4, plus 3f of 3's, and f of 3 is 5, so 3 times 5, plus 2. And then lastly, I get a negative g prime. G prime is 7, so negative g prime is negative 7. So I get negative 9 times 9. 15 plus 2 is 17 times negative 7. That's negative 81. Plus, well, it's going to turn into a minus, actually, because I'm taking a positive number times a negative. So minus, that's a 9, 119. Answer being negative 200. So, again, the lesson learned: when I have a table, look at the function you have. First, find the derivative function in terms of x. Then you can worry about plugging in your numerical value and going to the table. Problem like 8 gives people trouble. These are parameter problems, basically, where I throw in a D, some miscellaneous letter of the alphabet that represents some constant. These tend to wig people out a little bit. It's really not that bad. Again, big picture here is this. I'm finding dy dx. This is y. So dy dx, I want y prime. What's going on? I'm dividing. So quotient rule. FG, g squared minus prime the first, prime the last. So let's go ahead and set up our little f and g's off to the side. I mean, you may not need to do what I'm doing here. I don't either. I'm just showing it for demonstration purposes so that, you know, anyone can kind of follow along. So my f is my top function, x squared plus the constant d squared. My g is x squared minus the constant d squared. Okay, here's where people get wigged out. They're good at this. They say, okay, my derivative of x squared, power rule is 2x. And they say, my derivative of d squared is going to be 2d. No. Remember, d is a constant. So d could be a number like, let's say, 8, which makes d squared 64. What is the derivative of d squared? It's 0. If you have a constant and you square it, it is still a constant. And the derivative of any constant is 0. Keeping that in mind, my g prime derivative of x squared is 2x. The derivative of this constant squared is still a constant, so it's still 0. And we plug in. So f prime is x squared. I'm sorry, it is not x squared. F prime is 2x times g, which is x squared minus d squared, minus f x squared plus d squared times my g prime, 2x, and then my g squared is my x squared minus d squared quantity squared. Okay, so what do? I'm gonna move up here. I distribute. That is 2x to the 2x cubed, sorry, minus 2xd squared. Now, when I distribute 2x here times x squared, that makes 2x cubed, but I'm also distributing the minus, so that's negative 2x cubed. Well, that's nice. Those cancel. And then when I distribute this, 2x d squared, and then distribute the minus, it's minus 2x d squared all over our denominator, x squared minus d squared squared. So combining these two like terms gives me negative 4x d squareds. Negative 2 of them minus 2 more. And then over our denominator, x squared minus d squared quantity squared. Easy peasy. So, like I said, I am a huge fan of multiple representations, tables, equations, verbal descriptions, and yes, I can do product rules, quotient rules, whatever, with graphs as well. Now, remember when we talk about this, if I'm talking about what is like f of something and what is g of something, I'm looking for y values. When I talk about f prime of something and g prime of something, I'm talking about slopes. Specifically, I'm talking about slopes of tangent lines. So this is one thing we need to make sure is crystal clear before we go any further so that we know what we're looking for. So again, just like this problem up here where I said, get your equation for h prime of x before you go looking at the table, same applies here. I know I need an r prime and a w prime at the numbers 2, 4, and 1 before I worry about 2, 4, and 1 or any graphs. let's derive the equation for r prime. So r prime of x is, well, that's an f times a g. It's a basic product rule. So that's going to be f prime g plus f g prime. You can put the of x's if you so choose. W prime, that's going to be quotient rule. My top is, so I'm going to have f prime g minus f g prime all over g squared. So when I say find r prime of 2, I'm going to go to this equation and I'm going to plug 2 in. So I'm going to have f prime of 2 times g of 2 plus f of 2, g prime of 2. Basic product rule. Now we go looking. Again, when I say g and when I say f, remember I'm looking for y values. So on the graph of f at 2, right here, I have a y value of 3. So f of 2 is 3. Over here, g of 2, here's g of x. G of 2 has a y value of 2. When I look at the primes, f prime of 2 means I'm here at 2, but I don't want the y value. I want the slope, which in this case is 0. G prime of 2, I'm at here at 2. I want the slope. It looks like it goes down 2 over 1. So negative 2 over 1 is negative 2. So I get 0 minus 6 or negative 6 for r prime of 2. Okay? That's the basic idea here. F and g are y values. F prime, g prime, they're slopes. So when I'm doing, and I'm just going to go ahead and circle this because that one's done. W prime of 4. Again, W prime was my quotient rule. F prime g minus fg prime over g squared. So I'm going to have f prime of 4 times g of 4 minus f of 4 g prime of 4 all over g of 4 squared. Okay, now that we've got our equation set up, now we interpret. So here's 4 here, here's 4 here. So I'm going to have something times something minus something something all over something squared. I'm just going to knock off all the g's and the f's first. So f of 4 has a y value of 2. So I'm going to replace where this is with a 2. G of 4, well, that was easy. It has a y value of 2 also, which makes g of 4 squared 2 squared. Cool. So now I need f prime of 4, which means I want the slope here. It appears to go over 1, down 1. So 1 over negative 1, I'm sorry, negative 1 over 1 is negative 1. And then the slope here, rise 2, run 1. That is a slope of 2, which gives me negative 2 minus 4 over 4. Negative 6/4 is negative 3 halves. So this is negative 3 halves. And then there was one left. This one I think you guys are going to like. It is the easiest one of the bunch. And it'll also let you know why I teach what I teach in what order. So if I'm looking for W prime of 1, again, that was my quotient rule. So I need F prime of 1, G of 1, minus F of 1, G prime of 1, all over G of 1 squared. Here's why this is easy. So I'm going to get parentheses times, minus times, over whatever squared. I'm going to look here at F prime first. Here's 1. Notice something. I have a little thing here at 1. When x is 1 here, I have a little thing here. I refer to that as a corner point. Other people, other teachers may call that a sharp turn. Either way, I know the derivative of a graph or of a function at a sharp turn is that function is not differentiable. So this is a does not exist. F prime at 1 does not exist. You say, well, what about the rest of it? I don't care. If even one of those components does not exist, it means this answer does not exist. One bad apple does in fact spoil the whole bunch. So there you go. There's product rule, there's quotient rule, equations, graphs, constants, parameters, horizontal tangents. Hope it worked for you. Have a good night and peace.